Hi there, I'm Sandeep Giri from CloudxLab. As part of this guided project, what we are going to do is we are going to optimize a web application that runs a neural network by around 30 times. All right, so this is going to be extremely important for you. If you have been following through these projects and have attempted the last project that we built, in which what we did was we built entire web application that does the object identification by using a neural network. All right, we're going to take that project and we're going to make it extremely efficient by around 30 times, 30 times. All right, so let's get started. And if you are a software engineer or you are a senior software engineer, this problem you will face a lot, how to deploy a neural network efficiently. All right. So deploying a neural network like a web application is a commonplace. Everybody knows that part. But making it extremely faster is something that you learn as part of this. Or if you are a DevOps engineer and you're trying to build a service that does the neural network execution, this video is going to be extremely important for you. All right. So there are many concepts, there are many ideas that will be discussed as part of this project. So keep in mind that this is not only about a single topic. There will be many topics that will come in between, and I'll explain those ideas to you. All right, I'll explain those ideas that I've learned in last 17 years as part of this video. All right, so let's get started. And as part of this project, what we're going to do is we're going to open the project and we'll walk through it. Okay, so let's open the project here. Okay, let's open the project. Let me check if the sharing is correct. Okay, great. So let's open, first of all, CloudxLab.com. On CloudxLab.com, you will see the Explore courses. Under Explore courses, if you click on Guided Project and then you just search for Flask, you will see this one as first. This is the project that we did earlier. All right. As part of this project, this project which we did earlier is the prerequisite for this current project. All right. So what we're going to do is we're going to take whatever we did earlier and we make it faster. All right. So as part of the previous one, I'm going to do is I'm going to also give you a brief about the architecture of the web application that we built earlier. All right, and then we're going to jump into this. So let me open this in here. All right, so you can click on Start Now. Okay, and I might have to increase the font for you because things may not be very visible. All right, I hope the font is clear to everybody. All right, so this is good. Now, what you're going to do is you should also open this particular project. Okay, you should also open this particular project. This is essentially in continuation with what we did earlier. All right, earlier the project was taking 10 seconds. Now, what we're going to do is we're going to make it extremely faster. All right. As part of this, not only we will learn how to make a web application faster, we will also learn how to break a big service into parts. When there is a big service, we generally call it monolith. Monolith means made out of single stone. All right. And when you make something, a single stone, you can't really break it into parts and separate it. You cannot, it's not modular. It cannot fit on multiple machines. So therefore, the most important part of software engineering is to be able to refactor things. We call it refactor. If there's a big function, we break into multiple parts. We call that refactoring of the function. Here, we are going to refactor a big web application into two parts. One is a web application, and other will become only the service that runs the neural network. All right, that is another advantage of this approach. So as part of this, you learn multiple things. Okay, so if you have built the previous one, you don't need to delete it. You can utilize the same one. All right, but nevertheless, we will assume that you have deleted or you have deleted the virtual environment. But if you have not completed the previous project, please do it again, and do not delete the environment, okay? All right, so that's what we're going to do. And all right, I'm just going to mark it complete because there's nothing to do here. All right, so first thing we are going to do is we are going to create this. All right, or let me walk you through what we did earlier, and then we will basically talk about it here. Or okay, so earlier we basically built a Flask application which was deploying, which basically was which contained HTML, which contained CSS, the style sheets, which contained the backend Python code. So that was a composite application, and that was running on the server side. It was running a neural network after loading the weights from the file. Okay, so this was a very, very important learning in the last one. So we did not want to couple these two projects together because otherwise it becomes a bit messy. Now, first of all, what we're going to do is we are going to build a simple program and measure how much time it takes. All right, let's just start with that. So first of all, we are going to this folder. Okay, CD image classification that we built last time. Okay, and I'm just going to utilize the same folder structure. Okay, so my environment exists. If you've deleted the environment, go back and create in the previous one. Okay, finish the previous one, mandatorily. And then let's create a new file. Remember how we created the file using the VI, or you can use the Jupyter. If you go to control panel or you go to files, you can say new file and create a file. But we are going to use VI. VI is very efficient, and you should be handy with VI because most of the time you will be dealing with the server environment. On server environment, the VI is the one that works. All right. So this is what it is. And in case it is already written, okay, you can quit it. Okay, how do you quit it? By as you open VI, it opens in the what do you say, command mode. So you can press colon and Q. All right. So all right, I just resized my window so that I can see the cursor. Sometimes this is a little buggy, so it doesn't look. Sometimes if you can't see the cursor, you can press Control L and it clears the screen. Okay, so since I already created in the last run, what I'm going to do is I'm going to just delete this folder, delete this file. Fine, now I've deleted this file. There's right in this image classification app, my old app is there. All the things that I did last time is there. Now moving ahead here, I'm going to create this file. All right, and I'm going to copy paste these into this file. All right, press escape and press colon and WQ. All right, so I'm just going to decrease its window size. I think it is better to just be this way. I like, right? Okay, so never mind. So now this file is created. You can take a look at the file, this cat test underscore this. You can press tab to autocomplete the file name. So here we go. All right, I'm going to refresh it once so that the window looks better. Okay. All right, since we have put the Jupyter in the frame, it generally takes a bit of time to get used to these iframes. Okay, now moving ahead. So this is the code. What we're going to do as part of this code is, okay, what we're going to do as part of this code is we are what we are doing is this is a very simple program, and this we are doing for testing client. Okay, we want to build a simple program to understand how much time the neural network is taking. Okay, so here we are importing the TensorFlow libraries. Okay, and then we are importing NumPy, and then here we are creating the model. All right, notice this we imported and we created an instance of it, and then we are defining a function called get classes. What it does is it loads one image path, whatever you pass as the argument, and then here it is basically converting the image to array using this image object. Okay, now further it is basically pre-processing it, and pre-processing input is coming from Resnet, and it basically converts the image such that it can be fed to the model. This is the point where we are basically running the model. Further, once we got the predictions, we are decoding them using this one that we imported from Resnet, and then we are printing the predictions and returning them. All right, now we're calling this function from the main method. This is how you define the main method. So basically, if you this program can be used by another programs. Therefore, it is better to use this one so that when somebody imports it, this does not get executed. All right. Although if you don't keep this, even then it'll work fine. Okay, now here we are saying the name is this file. This file is essentially something that is there in CloudxLab. You can just take a look at this file if you want. Okay, but you'll have to copy this to your home directory. Okay, so I can say cp this file to my home directory using this, and then if I go here in files, okay, all right, it is coming up. All right. So usually a better thing to do is when you want to deal with many files, open Jupyter in the new tab using my lab place. Okay. So here I've copied it to my current file. So this is doc.png. Okay. So this is the doc.png. Now let's go back to here. All right. So this image is what we are calling the get classes with. And this, when you call the get classes, it is going to give the results. Okay, now run it. All right, so the cool part about Unix is that you have so many utilities available to do lots of cool magic. Okay, so like for example, there is a command called time. Okay, what time does is time basically measures the time taken by any application. All right, of course you can use a watch and measure how much time it's taking, but time is a way more efficient way. All right, so here we are running this Python program. So time followed by Python and followed by this. This is essentially running this program, Python followed by this argument. And it's taking time, you can observe that, right? So it's loading the neural network and it's also printing the result. So it has printed that these are the titles. So it says that standard poodle is this much, and and golden retriever is this much. So there is a standard poodle and the golden retriever and otter hound. Okay, these are the probabilities that it has printed here. Now, this is the usual one. Basically, this is how the neural network runs and gives the results. But the more important part is this part. Okay, more important part is this one. So this is the time that it is taking. So the real time that it is taking is around 18 seconds, which is actually crazy. Okay, and it is not just by luck. If you run it 3 times and take the average of the 2 which are most common, then you'll find that it's not a problem with the system. So here it's taking 11 seconds again. Okay, and let me try more. Know more about this time command to understand what it means by user and system times. And okay, so again 10 seconds. So we can comfortably say that it is taking 10 to 11 seconds. All right, so the magic part about it is that we can bring it down to 0.2 or 0.3 seconds. All right, let's get started here now. So that's what has been done. Okay, all right, so basically you can try the same application that we did last time. In that, what we did was we built a web application server, we observe the time taken, and you will observe that it is going to take 10 to 21 seconds. Okay, I mean, it varies between these two. Okay, so you can just assume for now that because the best two are 10, 11, so those are the most common one. So we are just taking the next one. Probably in the first run, when you were running, when we ran it using Python, it compiles and it generates .pyc, and probably that takes a little bit more time. All right. So now is the important part. What is it that we're going to do with the web application that we built first to make it efficient? Right now, we just tested, and the simple approach of calling the neural network is taking 10 seconds. Can we optimize upon that? All right. So what we're going to do is we're going to dissect the entire process. All right, we're going to dissect the entire process. I'm going to scribble a bit and going to draw a little bit more on the screen. So I'm going to use iPad to do that. Okay. All right. So what is it that we did in the previous one? Okay. So what we did was we built a web application. This is your web app, and to which the user uploads an image. Okay, and we give the predictions, right? We give the predictions. We predict whether what is the various probabilities of various objects that are found in the image. All right. So right now there are many things that it is doing internally. When the image comes from the user, it saves it in a file, right? It also loads, okay, right? It saves file, then it loads weights of neural network, right? And then it creates neural network, and then it executes. Okay, executes neural network. Okay, what it means by executed, if you remember, or if you've studied neural network is nothing but bunch of layers. Okay, or you can say a lot of numbers that get multiplied with the image until multiplied and summed and multiplied and summed and few more functions in between, and after that we get the outcome. Or you can say that we do lots of matrix multiplications and then summations, and then we get the outcome. Okay, that's about the neural network. So that is called the forward pass or execution of neural network, or you can say that it's a inference time of a machine learning model, right? But these parts 1 and 2, okay, take a lot of time. So this one is going to load around 170 megabytes of data from file, and files are slower to read because in files the read speed is slow. So when you read it, it's going to take a couple of seconds to read a gigabyte file or a few MB file. There's a seek time and there's a read time. Okay, so first part is loading the second part that we actually confuse, right? We actually skip is creating neural network. All right. So after we loaded the weights, or after this model loaded the weights from the file, what it is going to do, it's going to create the layers, okay, and make the neural network ready for execution. Okay. So these two things, okay, are something that we can make it only once. Okay, if we take it out, if we take these two parts, and put it in another service or somewhere, okay, so that this does not get loaded on every time, because neural network is same, it's kind of read-only thing. Okay, neural network, it does not get modified during inference time, and we are only doing inference. Neural network only get modified when we are retraining it. Therefore, we don't really need to load it every time. Now, at this point of time, what people suggest is that, hey, why don't you, since it is taking time to load weights from the disk, why don't you keep it in the cache, right? Good idea, but that will only save us probably 1 or 1.5 seconds, because the main problem is not only loading the data from the file. It is, of course, loading. When we say caching, you could do the caching, and caching will keep the data in the memory. These weights which you are loading from the disk will be available in the memory, but that's not the only problem. Problem is creation of neural network. When you're creating neural network, what it does is it creates layers and layers and then wires the things together. Okay, that process takes time, and that's an in-memory object that is kept. So if we try to cache that in-memory object, is going to be, deserialization, serialization. And again, when you do deserialization and serialization, it's going to take again and again time. So caching is not a problem. Caching is not a solution to this problem. The common thought is that, okay, this part is taking time, so let's just cache it. No, we cannot cache it just like that. Instead, we will make it a service which will keep this entire neural network ready. Okay, so that's what we're going to do. And so essentially from this model, whereby there was an image, and then we were saving the image to a file system, then we were loading the weights from a neural network, loading the weights from our disk, and then we were creating the neural network, and then we were running the neural network. All right, so are going to break it into two services. Okay, we're going to break it into two services. Let me draw it. Sorry for the bad handwriting. I'll try to be better. Now, so there are going to be two parts to it. Okay, first part is going to be the web application. Okay, web application. And second part is going to be the service. Okay, now, second part is going to be the service. Okay, so, all right, now, one more thing before I proceed. A common other thought, people who are coming from Java background, okay? So what they do is, let me just undo it for a moment, right? So what they do is that here, what they do is that they would take the pieces 1 and 2 and keep in the static variable. And when the new request comes, they will give that the results, right? That's a common mechanism. Okay, and most of you would agree that that's a good mechanism, but there's a problem with that mechanism. The problem is that the moment you start using static variables in your Java web application, what happens is the service is not scalable. Okay, service is not scalable because the static variables remain on one computer, they are not on another, and so on and so forth. So there are the complications involved when you start using the static variables. Of course, we are going to do the same thing. We are going to partially use the static variable, but in a wiser way. Okay, so we are going to do it in a wiser way. And also the static variable can only be shared amongst the threads in the same virtual machine of Java. All right, so or see, but here when a request comes to the user, in case of Flask or Django, when a request comes from the user, every time a new process is created, and therefore it is hard to share the memory between the two. All right, it is definitely possible, but that's not neat. Okay, that's not neat. I'm going to explain to you more. We want to break this application into two parts such that they become two modular parts. Let me just, okay, this side will be web app, okay, and this side will be the model server, okay, model server. Okay, so it looks all right. So this side is going to be our web app, and this side is going to be our model server. Okay, that's model server. Okay, now what web app will do is it'll take the image from the user, and then it'll basically feed it to in the request will come here, and it'll do all other kind of magic like saving the file somewhere or maybe trimming the file and serving the progress bar to the user and so on and so forth. Okay, and then the neural network part, we will keep it here. So as model server starts, okay, what it'll do is it'll create the neural network. Okay, this will keep it in the memory. Now, when the request comes from the user, at that point of time, it will run the inference. Okay, so here and here. This part will not get executed every time. Instead, this will basically be run only once. This will be run only once. Okay, this will be run only once. Okay, this will run only once, and this is inference. Okay, so when the image comes from the user, when user uploads the image, this is a Flask application to which the image is coming, and the Flask application is making a call to the model server. Model server is a service. What does it mean by server or service? It keeps running and waiting for the user to interact with it. It keeps running, it keeps everything ready. That's what is Flask, or that was a HTTP web server, that's an email server and everything. So it keeps running, waiting for client to come and connect to its port, and then it responds. So similarly here, our model server will keep the neural network ready, and then whenever the request comes from Flask, it basically does the inference. So if this was taking, say, 9 seconds, right, it'll only take 1 second more, because totally earlier it was taking 10 seconds. So 1 second for inference. You can actually put the debug statement in your the program, the test client we did. There you can find out how much time each part is taking. Now, that's a better way. Now, here, when image is coming to the Flask app, it is basically going to make a call here. So what we're going to do is we're going to build two separate services, and we'll make them interact. In the future project, what we'll do is we'll make it such that these two two services can run in separate containers, and both of them can scale well, right? Say, for example, in your company, you build this kind of service called model server for recognizing object. There could be another team who wants to use it. Now, when everybody wants to use it, so the model server would become more and more intensive. So model server will have to scale separately. Now, that's a beauty about making breaking a big monolith system into two parts, that both of them have separate trajectory or separate behavior with respect to scaling. The model server might be getting thousands of requests per day, and each request taking a lot of time. Therefore, you will need to scale it separately, right? Similarly, on the web application side, the web application probably is not that intensive, and it can handle to more number of users. Therefore, you don't need to run it on more servers. Okay, so basically the most important part is that the way we separated the database server from the web application, similarly, we separated the neural network server. We separated the model server to a separate machine. Now, this can keep on scaling it its own. We can basically say that, okay, auto scale, or we can ourselves keep on adding more and more machines to the second one, and it keeps running on more machines, and the Flask application could discover any of those, whichever is available. Now, that's a discussion in the DevOps chapter. If you have not taken the DevOps course, you can take it up to understand how to to build the service in a scalable fashion, which can scale, auto scale, and which can be handled. The next thing, very important part, is that both of them have different performance attributes. Okay, while Flask application runs pretty well on a server, not normal CPU, but model, specifically neural network, runs better when there are multiple processors as part of GPU. GPU or GPGPU, General Purpose Graphics Processing Unit. Okay, those were basically invented for gaming, but later on people realized that they can be used for mathematical computing, and that's where the value of those GPUs have become more. As of today, NVIDIA and other people are building these GPUs which can make your model run faster. So because the GPUs have hundreds of processors, and the work gets divided between them, and then you can execute everything extremely fast. So GPU becomes very obvious choice when you are doing deep learning, specifically training, and you are doing the inference. Okay, so your model server might have to be run on GPU, or might run on, say, 10 machines or 15 machines, while your web application will continue to run separately. All right. So just like we separate database server from the normal web application, similarly, we separated the model server from the normal web application. All right. That's the theory. And what we're going to do is for this particular example, we're going to use ZMQ or ZeroMQ. Okay, ZeroMQ or GMQ is extremely fast service and it works pretty well. And it's a basically a queue system. Okay, using this magical queue system, you can build lots and lots of mechanisms, and one of them is building a service. All right. Though there are multiple ways of creating services, and you might argue at this point of time that we could launch it in Java or Golang and something, right? That could be another thing. So keep in mind that both model server and web app could run different programming languages. The model server could be written in C, and the web app could be in Python, and they could talk very well. So this approach, the third advantage of this approach is that now the role of machine learning engineer or a data scientist becomes separate, and the web application developer or the full stack engineer or DevOps engineer, their role becomes separate. So on the right hand side, the data scientist or the machine learning engineer could basically focus on making their services faster, and while the web app people, they can basically focus on making their web application better and better. So the teams overlap, become separated. And that's the beauty about building services. And that's why at Amazon and other major companies, what people do is every team builds their services and they own their services, and other teams talk to their services, and rather than building the into the same code, they basically separate everything into services. All right. And the detail page that we built at Amazon, that was essentially a very good example of service. This service that we're talking about on the right hand side, we're going to use ZeroMQ, though there are many frameworks. One of them popular frameworks was Thrift. Okay, Thrift was by Twitter, I think by Twitter. It was extremely fast and performant. So that also you might like to use. Okay, so but for now, we're going to go with extremely simple one, ZeroMQ right now, but you're free to do the Thrift on even CloudxLab. CloudxLab has Thrift installed there. Okay, so great. A very important discussion that we did. Now, moving ahead, let's get back to the theory, get back to the practical part. Now, this is what has been explained as part of this, okay? The previous service was taking 10 seconds, and we're going to make it, separate it and handle it extremely fast. Okay, so and it's something that you will learn that, you know, a common question, and it's a valid question, that why are we getting into all of this, right? Then why are we making two web applications and trying to create our life, complexity in life? The main reason is the performance. Okay, imagine this, that you were building a face recognition system, and when you were building and this problem that we are solving, this is how we've solved it at DataView. Okay, we built a web application where we were recognizing face. And when we did that, we realized this taking 10, 15 seconds is not worth it, right? User cannot wait for 10, 15 seconds. Okay. Therefore, what we did was we did this and we brought it down less than 1 second. And it became possible. It became possible to run it on edge devices. Okay. Edge devices, as in the devices which are low end. Okay. So low end devices can talk to the server, which is running on a high configuration, and then that one does the processing, and here does the magic. All right, so that's an important part. That's the important part that you should keep in mind. Perfect. So this is what we have done here. Okay, so I'll explain to you as we go ahead. Okay, whatever we are doing next. All right, but you can read through this and it'll help you understand what's going on. Okay, now, so the service that we are going to build is using ZeroMQ or ZMQ. You must read through their documentation, okay? It will not only help you learn about ZeroMQ, but it will also help you learn about the concepts behind network service, concepts behind parallelization, or concepts behind building the queue system, and so on. This is amazing, service, okay? And I'm a big fan of this. All right. Now, let me talk about the project architecture. We've already talked about it. So we have the Flask server, and then basically user uploads the image, and then it goes to model server. Then it basically talks to the worker and comes back. Okay. So this is what we're going to do. This is going to run on another machine. Once it will initialize, and then it will create on every request. It will create a new worker and do that, while the model will remain loaded all the time. Okay. So let's move ahead. Okay. All right. So this is what is going to be. Basically, this is what I have just now explained. Okay. You should go through this, theory a little bit more, and you will get a better perspective. Okay. Now, here we go. So what we're going to do is we are going to, okay, let me just size. Okay, so here we are going to understand the directory structure. Okay, so first of all, we are going to create a high-level project. Since I already done it, I'm going back to the home directory. You can go back to the home directory by just saying CD and enter. Okay, CD and enter. Or you can go to the home directory by saying CD tilde. Tilde is like a wavy thing, just near your escape keyboard button, just below or above escape character. Okay, so there using CD tilde, you can go back to the home. Okay, and also, or you can give your absolute file location. You could say CD, or you can say CD $home, CD /home Sandeep Giri 9034. Okay, or you can walk around using cd dot dot and so on. You can figure that out. All right, so this is your main directory structure. So what we're going to do is we're going to break it into two services. First one is going to be the model server. Second one is going to be the Flask web server. This is the web server. This is the model server. Model server we are going to build using the ZeroMQ. The web application server we are going to use a Flask. Also, please notice that it is wise to create two different virtual environments. If you remember, the virtual environment that we talked about last time was that in a virtual environment, basically we can install different things and they will not interfere with other users or other apps. And therefore, it is always wise to keep your virtual environment separate. Okay, this you will see further if you go into DevOps. You will understand that when we are creating containers and launching, it is important to create a virtual environment so that we can launch it very cleanly. Okay, so that it doesn't mess with the entire system. Now, here this is going to be the virtual environment where we are basically install only the things related to the model server, like the all TensorFlow and Resnet and other things. Then this is going to be our server. This is going to start a ZeroMQ service and will listen on a certain port and respond to the question image that comes to it with probabilities. Now this is going to be the test client. This is just for testing whether it's working or not. It's always wise to create a test client. Okay. Also, one more thing that we are not covering in these projects is how to do the testing of these things. Ideally, in a realistic project, your project starts with test cases. All right. Your project starts with test cases. Therefore, always build the test cases first and service later. Though we demonstrated how to build a simple test case service, and when we debug, when we optimize, those test cases are very, very important. All right, so build the test cases. Test case is nothing but a way of verifying whether you have written the code. By writing another piece of code, you verify your another piece of code. Okay, so that's what it is. And then there's a requirement.txt. We will create whatever things we install here. We usually put it in the requirements file. As part of any project, you always create this requirement file so that you can, in single shot, install everything related to it and get the virtual environment ready. Okay, so that's a kind of standard. Similarly here, this is the Flask server, which contains HTML templates and the Python code to fill that HTML template so that we can talk to the browser really well. And here it might be that you are talking to databases, you're talking to other services. Let's say you're building you are basically storing the data that's coming from the user into database and then doing multiple operations. So all of that can be done here. Okay, so it will be done here, and everything related to the neural network and here it'll basically be in this project, in this folder. So there are two projects in this. First one, this one, second one, this. Here, this is the Flask environment, virtual environment that will creates this folder that contains all the symbolic links to the actual environment, and whatever we install gets installed in there, not in the parent, not in the common one. Here, app.py is the entry point in the web application. Whenever there's a request coming from the user, it basically maps it to the corresponding code. Okay, and what code to execute, what resource to give is controlled by app.py. Then requirement.txt will create this file so that whatever we are installing, we will keep a frozen version of those, so that particular version of the packages are here. And whenever we want to create the environment again, we can just say pip install -r followed by requirement.txt. Then here there the static, the images and other parts, and here there are templates. Okay, the templates contain the various templates for homepage and header and so on. Okay, so all the HTML, CSS goes here, while Python goes here, and so on. Usually you will break it down here. You'll create more folders to describe your work. Okay, so we are going to copy this part from the previous project. Okay, though we are going to create the environment probably, and so let's see how it goes. Okay, so that's what it is about. Let's mark it completed. Okay, I'm going to be a little faster because that way you'll pay more attention to it. Okay, so now we're going to go to home. Okay, we are going to run the deactivate, because while doing the demo previously, we activated another environment, right? When we deactivate, this gets removed, right? That's a sign that you are not in a virtual environment. Okay. Also note that virtual environment does not consume any overhead, memory, or CPU. Okay. Virtual environment is essentially like setting up a path. Okay. Now, we're going to do the creating a model server and the Flask server folders. Okay, so first of all, let's just check where we are. We are at here. Now we have to create the folder. Okay, we're going to create this folder. Okay, let's say mkdir Flask ZeroMQ app folder. Okay, since I already created, I'm going to delete it. Okay. All right, let it get deleted. Okay, so rm-rf, and given the folder name, it deletes the folder recursively and forcefully. So be very careful when you do rm-rf followed by the folder name. If you say that dot, it will delete your home directory. Okay, so be very careful, and there are commands like rm-rf and / that actually deletes the entire system. Okay, so be very careful when you do the RM. Okay, so coming back to it. So now that we are here, let's create this folder again. All right, mkdir, and that's it. Now, inside this folder, after using cd command, we are going to create the model server folder. Okay, we are going to create using mkdir. We are creating the model server, and then we are also we are also going to create the Flask server folder inside this. Okay, so now our present working directory is Flask ZeroMQ app folder, and we have got two folders. One is Flask server, other is model server. Okay, this is where we are going to create our model server. This is where we're going to create our web app server. Okay, now let's move to the model server folder. Okay, let's go to model server folder using the cd command and submit. Okay, it says it is correct. Let's move ahead. Now is the time to create a virtual environment. So what we're going to do is, if we are if we are not using a virtual environment, we can delete it. Here is the description of virtual environment that I have already given to you. Okay, let's move ahead. Okay, so here's a question that if we have a virtual environment named model env, how do we deactivate this environment? Using activate source this, using this or this. I'm not going to click on submit answer. Right, track that out. Moving ahead. Now here, basically we have to be in the model server folder. We are already there, so we don't need to do this command. Okay. Also, please pay attention to every command that you type, you read through it. Okay. Know what you're doing. The most important part is do not blindly run the commands. Okay. Know what you're doing. You should be able to correlate why exactly we are doing something. Otherwise, what happens is you get into this robotic mode and you want to finish everything. Okay. And then once you mess up something, you go to the beginning and start doing again. Right. That's a good way to get something done quickly, but not, getting the hang of things. Okay. So here, virtual environment model env, it's going to create this environment. Okay. And we're going to activate this environment. All right. So it is done. Now we can do the activation. So we have activated it. Okay. Moving ahead. So let's just check if it's working. Yes. All right. Now, the important part is that we will use the pip freeze to create the requirement file that we'll do later. All right. Now here, you can just see using pip freeze that what things are installed. Looks like we have not installed anything in this environment so far. Okay. So what we're going to do is we're going to first of all install ZeroMQ. This is the main service that we are installing in this environment or for the model server. Okay. Then we are going to install the setup tool, upgrade the setup tools, and we're going to do remaining parts of it. Okay. We are done here. It took a long time, but it is finally done. It has installed setup tools, gRPCO, ZIO, and TensorFlow. Now we're going to install the Pillow. Pillow is the image library. And then once we're done with Pillow, we are going to keep everything in the requirement files. Okay. Now, this basically the arrow, what it means is that whatever pip freeze prints on the screen, okay, if you print everything on the screen, these are the various things it will print. These are things that are installed, and it's going to keep those in this file. Okay, arrow means that whatever is the output coming from a program, the greater than sign takes that into a file. All right, so that's what it does. Now let's move ahead. So now we have requirement.txt that contains all the packages that we need for this. This is just, it's not really required, but it is good practice to keep everything in a folder. Otherwise, if you go again to do this, it will not be great. Now is the time that we're going to create the Resnet server. We are going to use VI in order to create the server. Now let's start. So we should be in this folder, model server folder, which we are already there. And now all we have to do is create this file called resnet.py and put it in here. Okay, so what I'm going to do is because I have to walk you through this code, I'm going to use Jupyter in the CloudxLab. Instead of this window on the right hand side, I'm going to go to Jupyter. Okay, open it in the full window. Okay, and there we go. So where is our folder? This is the folder. Okay, and inside this is where we are going to create our server. Okay, so we're going to say here, I think it's going to be text file. Okay, all right, let it open. We'll change the name from untitled.txt to the name that is mentioned here. Okay, to the name that is mentioned here. Okay, how do you change it? Just by changing here. Okay, now let's, it's suggesting that we should copy paste. Instead of using VI command to edit it, we are using the Jupyter. Okay, it's the same thing. As long as the file is in the right folder, everything is same. Okay, if you are comfortable with VI, you can do with VI also. That's not a problem. Okay, instructions are written in that. Now let me walk you through this model server. This is an important part. Okay, so first of all, we are importing these the image manipulation libraries, and then we are importing threading. This is a Python project. Then we are importing ZeroMQ ZeroMQ, right? ZeroMQ, what do you say, the library, and then base64 we are importing and NumPy, TensorFlow, then various classes or modules from different packages, right? Now here's the important part. So we are starting a session. In case of TensorFlow 1, there is something called TensorFlow session. Therefore, we need to create a TensorFlow session so that we can share the same session with every request that is coming from the user. Then we are loading the ImageNet and also the graph. In case of TensorFlow, every computation is a graph. Okay, so 2 plus 3 plus 4 is like a graph in which the node is the operator and the operands are on the leaves. Okay, so every computation in TensorFlow is represented as a graph. So we have created the graph. The graph runs in the session. So we needed that. And then the model is there. So model is basically part of the graph. Okay, so we basically got the default graph. So we need these for execution. Now this is our main server. Okay, this server is going to be run as a thread. So we want to run it like a thread so that it keeps on running in the background and doesn't, suffer from other problems, or it doesn't exit. Okay, now here we are saying that basically this is the way we hand over events to the service. Okay, so we are saying that self dot underscore stop equals this, and these are the standard way of creating thread. Now, so if you say server stop and server start, right, you can basically do that. If you can just say server dot stop, the process will stop. And if you say if you want to start, then we'll have to say server dot start. Okay, I'll just show you that part. Now, these are the standard way of controlling our service. Now, here we go. This is the method that we have to create in a thread. Okay, that will be executed by the thread. Okay, thread is essentially a unit of parallelization, making things run in parallel. Okay, so that multiple units of code can run in parallel. Therefore, we create threads and we do thread.start and so on, and they run in the background. Now here is the ZeroMQ. This is where we are initiating the ZeroMQ conversation. We are saying that create a context. Context is like create a new session, or you can say create a new object of ZeroMQ. Okay, now here we are saying that there's something called front end. Front end is the one that is going to handle all the requests that are coming from the user. Now, basically here we are saying that bind the front end to the local port at 5576, meaning when the user is requesting or connecting to this service, which is running on 5576, it is going to go to the front end. Now, back end is for our own internal consumption. Okay, these are parts of the ZeroMQ. Okay, and basically we are going to, here we are tying it with this. Okay. Further, this is a poller. Poller means that it will keep on polling if there's a request from the user. Okay. And we are registering front end and back end with the poll. Whenever there's a request coming from the user, we inform the front end and the back end. Okay. So here we are saying that while this service is not stopped, okay, while the service is not stopped, first get the sockets. So here, this is where it keeps waiting for the users. When user is, or our user of the service requests something, this is where it waits. Then for each of the sockets, right, it basically checks if the front end is there or not, and then it basically checks whether the front end is really existing. If it is, then receive the data from the user. Okay, first it receives an ID, and then it receives the JSON data. What is JSON? JSON is a data in the form of key value pairs. Okay, so the key value pairs in the curly brackets. JSON is JavaScript object notation. So whenever we have to transfer an object to a file or over the wire, it's better to put it in a string format. Okay, or in some other binary format which others can understand. So JSON seems to be a very good or very established mechanism. Earlier it used to be XML, but XML, since it has closing tags and there's a lot of overhead of defining things, therefore JSON is little efficient than the XML. Okay, so most of the RPC or remote process call or most of the services, the interpret process communication happens via JSON. Okay, of course, there are these thrift protocols where the communication happens using binary, but here the communication is happening using JSON, the plain text. Now, when we got this object from the JSON, from the user, what we're doing is we are creating request handler. Okay, this request handler is our class, and we are starting this request handler. And this request handler is a thread, which means that when we say handler.start, it won't wait here and it'll go ahead and start listening again to the user's request. And once, right, also further here we are basically doing the, informing the front end that the back, right, informing the back end that the front end is done. Okay, so there is nothing much we are doing in the back end part. All right, now let's take a look at the request handler. Okay, this is the more important part. So here, first of all, this is an object in a JavaScript format, JavaScript object notation. From that, we have defined that that object must contain a key called payload. Okay, this is something that we have agreed upon. In the payload, the image will come as a string. And how do you convert image into a string? By encoding it using base 64. Okay, so here we basically converted this string. We took the web application would take the image from the user, save it to the file, load it in a array, and then convert that array or bytes into the base 64 format, which is a text format representing the bytes. Now, then the web application will create the JavaScript object and send it to this guy in the name of payload. And so here it's decoding that and then saying image.open and converting this string into the binary data and opening that image. This is the image that is representing the data that has come from the user. Now, the standard part, resize the image to this size, convert it to array, and then do the pre-process using the Resnet. And then here is the part where we are doing the prediction. Okay, so we are saying with graph as default, with this session, run this. Okay, run this. So we are only running it. We are not creating the model. The model creation has happened here. Okay, here we loaded the model, we kept it ready, and then whenever the user request is coming, it is only doing the predictions. Okay, at the line number 96 is the place where we are doing the predictions. Okay, so the only time is going in this basic processing and prediction. So here we are decoding the predictions and sending it back, and that's pretty much. Okay, here we are iterating it, preparing the string to be sent back to the user, and here we are sending it. Notice that we are sending back a dictionary. Dictionary is a key value pair collection, and then we are setting the preds as one of the key, and we are putting this array or whatever it is here. I think, yeah, it's a string here. It's a string we are putting in this. Now we are returning it. Now, when basically this is the entry point for the request handler run, it is going to run it, and then it is going to call the self.process method. Okay, self.process method, and while running, it will tell the worker to inform the backend endpoint. That's it. Okay, and once it is done, it is deleting the message. Why? Because message might be big and it would be retaining it in the memory. So as soon as the thread is done with the processing, you should drop the message. Okay, usually it is automatically deleted, but since we are not sure here that it will be deleted immediately or later, so we are enforcing that it should be deleted immediately. Okay, that's pretty much. So we define two parts to it. First one is the server, and other part is the request handler. Request handler does the entire processing. Server keeps listening and keep on calling request handler over and over. And here in the main method, we are saying create an object of the server, and then we are starting. Notice that here we are calling start method while we are defining run method here. Okay, run method here. Why are we doing this? This start method comes from the thread. Okay, so when we say start, it's not going to wait for this method to finish. Instead, it will immediately return and run the run method in the background. Okay, there's a magic about threads. Okay, so this is the main method and so on. So request handler is a thread and server is a thread. Okay, so both can run in a background, and that's how it is doing. So let's just save it. Let's just save it and see if it works or not. Okay, we are going to, all right, this is what is described in this. Okay, right. So do read through these text. This is going to be very helpful for you. Okay, now let's create, now that we have created a server, now is the time that we want to understand what exactly, whether exactly it runs or not. Otherwise, there's no point of it. So let's create another file called test client in the same folder. Okay, here we're going to create, where is the folder? This is the folder. Now here we're going to create another text file. Okay, so here we go. We are creating a test client, and going back here, we are copy pasting this code. Okay, I'm going to walk you through that. So now here is the important part. So what we are doing is we are testing our server that we just now created. Okay, but we have not run that server yet. We're going to run it soon, and then we will basically test it out. Now here we go. So take a look at this part. So what we're going to do is we are going to test this program using this image. Okay, so we have already check this image, and we are basically calling this method with that. So first of all, it's randomly creating an ID, that because in case of our server, the way we have implemented, every request expects an ID and payload in the input. Okay, so basically this is what we are going to send. This is a dictionary. Dictionary is a key value collection containing two things: one, payload, which is an image string, and second, the request ID with the name _ RID, okay, which is a random value. Now here we are opening the file, loading it loading it using this this read method. So everything is loaded into memory, and then we are basically encoding it to the string, and then we are talking to the ZeroMQ here. Notice that we are talking to the same port as this one. In a real scenario, when we are dealing with the server, this host, which host it needs to connect to, needs to be dynamically discovered. Okay, there are multiple ways to do it, but for now, let's just think that these both of the systems are going to run on the local machine. Okay, usually both of these services, the Flask as well as the ZeroMQ, they're going to run on different machines, but here we are running on the same machine. All right, now here we go. So we are saying that the client is started, and we are basically polling it, and then we are sending the data. Okay, and once we have received the reply, we are processing the reply and printing the predictions. Okay, printing the predictions. Usually what you should do is you should put the print statement everywhere and notice what is happening where. Okay, that is the important part to do the debugging. All right, so now that we have created this test client, so we'll need one more terminal. Okay, so we have one terminal here. Okay, and other terminal. Okay, where is my other terminal? Yeah, here is another terminal. All right, so okay, so let's now, okay, let's just submit it, move ahead to the next step. Okay, now one more thing is that we have to start this. Okay, we have to when we run it, we'll have to stop it using control jet. Okay, so the way it is designed, the service is designed that, okay, that it won't stop. Okay, it won't stop, it will keep running in the background. Okay, like here it is started right now. So I said Python Resnet _model _ server, so it's running. Okay, now let's wait for it to come up. In the meantime, we'll get another environment ready. Okay, so here we go to the same Flask ZeroMQ app folder, then model server. not model, yeah, now model server. And here we will activate our using either source, or we can just say dot, because at the end of the day, here we are trying to execute this file called activate, which basically sets the path and sets the prompt. Okay, now this is where we are. Okay, now here this file is here called test client. Okay, we are going to run this test client. Okay, so you can see that this happened very quickly. Okay, so let's run it again. You can see we have brought down the time to instant. Let's just measure it using time. Okay, so it's 0.159. Can you believe this? It is 0.157. Okay, same object recognition is taking less than 2 seconds, less than 0.2 seconds, not 2 seconds. Earlier it was taking 10 seconds. Okay, so it's wonderful. It's wonderful. Actually, we have improved the performance by 50 times. Okay, we improved the performance by 50 times, more than 50 times. All right, so now here that is actually very, very impressive. So basically this test client is talking to ZeroMQ server, which is running here. You can see that we are printing all kinds of things here, and then right, let me just drag it to the nearby one. Okay, this is where our server is running, the ZeroMQ server, model server, and this is our model server's client. Okay, now in order to kill it, it requires a bit of hard work, because we are not able to cancel it using Control C. So when you press Control Z in Linux, it sends the process or suspends the process and keeps the process on the hold. Okay, that's actually there. If you want to still run it, you can say BG and it starts running. It starts running in the background. You can test it out. Okay, so now we press Control Z and we sent it to the background. Okay, though it is giving the output to the screen, but we got our prompt back. Okay, in order to kill any process, what you can do is you can do PS and notice the ID of the process. This is the Python command that is running. Okay, we want to kill this one. Okay, so we'll say kill -9 and this. What is -9 here? We are sending a signal called kill. -9 represents the -9. 9 represents the kill signal, because there are many signals that you can send to the process, like suspend, activate, and kill. So those kind of signals that you can send it. Like if you send kill -11, that means you are asking the process to just suspend instead of getting killed. Here it's terminate. Okay, so it is going to get killed. So right now we just killed the service. If you try to run the test client, it will fail. Okay, it'll keep on waiting for that. Keep on waiting for the backend, but nothing will happen. All right, so this way we basically executed the environment. Now is the next step. Okay, so we tested our application server with our test client, and it is doing wonderful. Okay, it is doing wonderful. Now let's get started with the next step. We will integrate this service into the Flask application. Okay, so here we go. So we will go into this folder. Okay, we'll deactivate the environment. Why? Because we are right now in the model server environment, and we'll either do cd ... and cd Flask server folder. Okay, right now all of this is empty. Now the next very interesting tool we have used here is called Rsync. Rsync is remote sync. Okay, so remote sync, Rsync is an extremely powerful tool. Okay, in case you have to copy your music, or in case you have to copy files from remote server every day, use Rsync. Okay, what it does is over the wire, it checks which data is already existing in the target place, and it only transfers that data. Even if there's a big file of say a few gigabytes you are transferring every day, like taking a backup, it will just transmit that portion of file which is new. And that's an amazing part about Rsync. And therefore, Rsync is used for backup systems. Rsync is used for upgrade systems at many places. And Rsync was actually designed by the author to synchronize the movies or synchronize the music of his wife. Okay, he was doing PhD and he ended up writing his PhD thesis on how how to synchronize files because he needed to copy the music over very very low bandwidth. Okay, so this is an amazing tool, and this is we are going to go to use it locally. So here we're saying rsync A and B means archive and verbose, and show me the progress. Okay, and copy everything in this folder. Okay, home folder / image classification app yesterday, I mean the previous one that we did, and we said that from here and right, so from there to the current folder. Okay, to the current folder, and we are saying that exclude the environment folder. Okay, we are saying exclude the environment folder. Right now this folder is empty, but when we say this, it'll be full. Okay, so you can see all the things that we built in the previous tutorial are here. We have the app helper, we have app.py, we have doc.png, we have static, we have template, and we have test client without ZeroMQ that we created today in the beginning of this tutorial. All right, so now we go into this folder. Okay, we are already there, so we don't have to worry. Now let's create a virtual environment. Okay, because that's the thing that we did not copy from yesterday, because today we don't need to install the Resnet and other TensorFlow things into this environment. Therefore, we don't need to copy that environment because this will be way more lighter, right? So now let's activate this environment. Okay, so you can see pip freeze and you will see what all is there. Okay. So you can see there's nothing installed yet. So we need to just install Flask and ZeroMQ client. Here we don't need ZeroMQ server, but since both of them come together, we are installing. Okay, so ZeroMQ server and client are same thing actually, and it's the way it is designed is very interesting. You should take a look at that. Okay, so here we are saving the frozen version into requirements. Okay, so this is where we've kept everything. All right, now we submit the answer. Wonderful. So great. So we are able to achieve something really good. Today, we are going to further modify the code. Remember the app.py code where we were doing the prediction. Now we have removed the part where we were running the neural network. Instead, where we are talking to ZeroMQ, that's the part that we are going to keep in this. Okay, I'm going to walk you through this code very quickly. All right, so we are going to create a file called app.py here. Okay, again, you can actually just go to here and okay, Flask web server and app.py, you can just say edit. Okay, I'm just going to delete everything and I'm going to copy this from here to there. Okay. All right, let's save it. Great. So you can see that here, what all we are doing here, we are saying that when the request for / comes to the server, after importing everything, we are initializing the Flask application. Then we are saying that whenever there is a request coming from the user, send it to index.html. When the request for uploader comes and there's a method called post, we're going to extract the file content from here, save it in a file. Then we are going to encode it to base 64, meaning converting the binary data to as image to the string. And then we are initializing the ZeroMQ client and connecting it to 5576. Okay, in case there is another user who is using it, use some other port and change it in the model server as well. Okay. Now, further, here we are registering it and we are handling it. Once we get the predictions, we are rendering the template just like here, just like the previous project, and we are sending this. Okay, so this part remains the same while this portion of app.py is changed. Remaining part remains the same. Up to here, everything is same. Only this part had changed in the previous project. Okay, so instead of this running the neural network, we are sending the request to the other one. All right, we are almost through. So we are going to we are going to run this program called app.py. Okay, Python app. And before that, please notice that it is CXLN 4. Okay, and we can just say if config and find out the IP address of this machine. So it's .4 for me. It could be something else for you. Okay, so we are going to run this application server. Okay, so we are launching the web server. Okay, on one hand, we started the web server. Notice this port. Okay, notice this port. It is 4114. Now, in another terminal here, we are going to start. We are going to start the model server. Okay, how do we start? Notice the environment name. Okay, here it's model env. Here the environment name is Flask env. Okay, all right, so in the Flask env, our web server is running. Here, the model environment, we are running our model server, which will be doing the main neural network heavy lifting. Okay, so now these two servers are running fine. Okay, now is the time that we basically test our process. Okay, so it's running on 4114. Find out the public IP address using IP mapping from my cloud, my lab. So here, this is the IP address. The public name is e.cloudxlab.com :4114. Okay, great. So it seems to me it's working. So you're running two server, blocking two services. One is the model server, other is the web application server. Web application is running on this port and this host. Okay, now we are going to say choose file. Okay, and let's say I'm running this one. Okay, so you can see that the balloon is 99.7%. So it is working perfectly fine. Also, please notice that it is very instant. It is extremely instant. Okay, it's extremely instant. Okay, so extremely instant. So unlike the last time it was taking around 10 seconds, now it is around it's less than 0.2 seconds. Okay, so we are done. Congratulations, you have learned how to build a service-oriented architecture, build two services, also learned about the optimization techniques. All right, I hope you found this very useful, but please make sure that you do all the steps by yourself, try everything in the lab. Also, please feel free to share this video as well as the project. Thank you very much. Have a good day.